Hello, welcome to part 2 of SCS ROWCAD Draw Quick Start Guide video tutorials. In this episode, we learn how to build and modify the final circuit, perform a steady state, and total interference study during fault. There are two ways to open ROW. You can either launch it directly from your ROWCAD project, or you can start ROW from SCS Software Application folder. Double-click the right away icon to start the ROW program main interface, which consists of 10 large buttons. Through Project Management button, you can open new, existing, or recent project from your computer. The Settings screen allows you to define certain system parameters for the ROW inputs. In the Limits tab, you can define a set of limits to accommodate your project. Those limits should be increased conservatively in order to maintain an acceptable performance. The Frequency and Units screen allows the user to specify case description, run identification, system units, and frequency. Build System Configuration is an important screen to import the ROWCAD data into this new scenario. To do so, set the ROWCAD input mode as cross-section, select Erase all existing data from the input list, and click on Import. Please note that if you have opened ROW directly from your ROWCAD project, this step has been done automatically. After the ROWCAD has been imported, we have the access to the System Central site as well as the terminal's information. Now let's get hands-on with modifying and building the final circuit, assuming that you have already calculated substation and valve grid impedances. Click on the Modify Circuit. Load circuit reference, which is 0. This is the target file to which the operations are going to be applied. You can view the circuit in GR Splits 3D. Type 1 in the New section, which determines the resulting file after the operations. In the Comments section, document the modification to be done on the circuit by typing a description for each one. Then click on the New button to start defining a new operation. Select the target terminal. Click the Self Data Modification button. Operation 1 is defined by using the Shunt Impedance option. Click on the New set. Choose Replace With option and enter the new impedance value. Choose Phase 4, which is 375 kV neutral, and enter section from 58 to 58. The substation is added in the new circuit. This will replace the 375 line tower impedance with the substation impedance. Click on the New Set button. Choose Replace With option and enter a large number as the new impedance value. Choose Phase 8, which is 69 kV neutral, and enter section from 58 to 58. This will remove the 69 kV line tower impedance since the two neutrals are tied at the substation grid. Click on the New Set button and choose the Replace With option. Enter the new impedance value. Choose Phase 1, which is pipeline, and enter sections from 16 to 16. The valve is added in the new circuit. Click the New button to start another operation, but this time click on the Mutual Data Modification. Operation 2 is defined by using the Insert Replace Connection Impedance With option. Click on the New Set button. Select between Phase 4 and 8, enter from section 58 to 58. This will connect these two phases at the substation location, where they both connect to the grounding grid. After both operations have been defined, click the Run button to create the final circuit model. This circuit model is the base circuit that can be used for various scenarios, such as load and fault conditions. To submit this file in the ROW environment, click on the Process button. Select Process Circuit number 1, then click Run. The Splits computation module starts. To examine the induced pipeline potential and various physical quantities, click the Plot and Report button. Select Reference Circuit 1. Click the regular Plot button and click on the Open button in the following screen to load the desired output. To examine the currents in the phase conductors, in the Output toolbox under Determine, select section Longitudinal or Series Currents. Enter 5 for starting bus and 7 for the ending bus for 375 kV line. and 9 and 11 for the 69 kV line. Click the Plot Draw button. The following plot appears. Now we will examine the induced potentials on the pipeline. Under Determine, select Shunt Tower Ground Potentials. Enter 1 for both the starting bus and ending bus numbers. Under the Terminal option, Terminal number 1, you can also enter 7 for the beginning section and 71 for the ending section numbers. Click Plot Draw button. To plot the holiday leakage current density, click the Advanced button. Select the Steady State option. Then under Data Types, select Inductive 1 cm² holiday leakage current density. Select Phase 1, which is the pipeline. Click Process. Save the CVS file. Click the Plot button, check off the Terminal 2 box, and click the Proceed button. The 1 cm² holiday leakage current density plot is obtained. Now we move on to fault scenarios. To create a fault scenario, click on Projects, save Scenario As, and enter fault 375 kV as the scenario name. Then click on Create. Next, click on Build System Configuration and navigate to the Terminals tab. Choose Terminal 1, then click on Energization and modify the energizations so that Phase 6 and 7, which are 375 kV B and C, are set to dummy. Here we choose Phase 5 as faulted phase because it's closer to the pipe along most of the corridor. Repeat the same for the second terminal. Click on Create Circuit. Select Update Terminal Energization and Central Site for Circuit Model 1 to avoid regenerating the terminal section output files. Terminal 1 and 2 in splits files are updated with the energizations. Click on Monitor File to bring a screen to specify the data defining a fault scenario. The monitored faults will be simulated based on the circuit number 1. The reference phase is phase number 4, while the faulted phase is defined as phase 5. The fault connection impedance is by default set to a very small value. The fault location can be optionally defined at every other tower. Select Source Current and Linear Interpolation. Click Define Source and enter the fault current data. Then click on Monitor Data to define the exposed phase, which is usually the pipeline under study. Phase 1 is selected. Then click the Process button and select Monitor Fault on circuit number 1. Click Run. For total number of fault locations, splits models will be created and launched. Click on the Total Interference to access the Creating Total Interference Model module. In this module, various MOS faults are created, one for each fault location. Choose circuit number 1. Make sure that Include EMF Terms is on. If this flag is off, the computation results from the MOS run will not include the inductive component. Select the phases that will be in the MOS model. In this example, the pipeline is selected. Then define the phases that will have observation point profiles, where physical quantities such as touch voltages will be evaluated. Since we want to have the pipeline coating stress voltage in this example, a profile on reference conductor surface is defined. Enter 30 for the distance between points. Activate Tower Selections and Energizations tab. Define the phases that contain towers which contribute to the conductive component of the interface on the exposed line. Select the tower grounding configuration. Define the tower GPR threshold here. Any tower having a GPR larger than 1 volt will be exported. Select the GPR energization type. Then click the button Create Only. The final MOS faults are generated in the Monitor Fault Store 1 folder. The total interference MOS models do not yet include the substation and the valve grid. We need to include them by using a template file. Using ROWCAD, open one of the mols files found in the Monitor File Store 1 folder of the scenario. Save this file as mols template under the scenario directory. Add the substation grid created at step 18 of Quick Start document at its correct location and connect it to the nearest tower that was exported by row. Here we want the connecting conductors to be coated with good coatings, in other words insulated, since mols only accepts below ground conductors. In a similar way, you can add the ground mat at the valve station site along the pipeline. Remove from the file all the conductors that were automatically exported by row, such as the pipelines, the towers, etc., so that the template contains only elements that need to be added. Go to the Define menu and select Delete Unused Characteristics. Click Select All. With all of the items selected, click OK. Save the file. Back in the Total Interference module, you can also set the number of towers to be exported to 50 on either side of the fault location to save computation time. Add a reference to mols template file. Click the Create and Process button. The files get created and are run immediately in sequence. Click Plot and Report to go to the reporting screen. Then click Advanced. Select the Fault Conditions option and select Conductive or Total mols Coating Stress Voltage. Click Process. Save the file. The program will then parse all the results file and build the envelope of maximum values encountered. Then click Plot. The following screen will appear. Click the Process button. The coating stress voltage envelope for the fault conditions is obtained. Thank you for watching.